Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI.
Welcome back. My name is Pat Denton. I am the Director of Sales and Engineering here at TTI. With us today from the YAGEO Group are Peter Blais, Senior Director, Head of Digital Development and Technical Marketing, and Simon Reuning, Global Technical Marketing Manager with the YAGEO Group. In Episode 1, we discussed big power, and so in Episode 2, we're going to shift gears and talk a little bit about little power. And the first question, explain to us what we mean when we say little power or low power and what that encompasses.
Well, I think when we start talking about little power, we have to think about all the sensing equipment that goes into factory automation. And really to set the stage and help everybody understand what's all involved with that, I want to take you on a small journey to a home improvement store on the weekend. So if you have plans on planting some flowers and you realize you need to get a fertilizer bag, well, you're going to go to your car, you drive to the home improvement store, you're going to go in, you're going to pick up your bag, you know already where the bag is located. You're going to go to the register, you have your little card, you check it, you scan it, you pay for it, you load it back into your truck, and then you drive back home and now you got your fertilizer back. Well, that's kind of the process that we have to start thinking about for factory automation. For us, we do all of those things automatically. We look up where the location is for the bag, but once you start implementing factory automation, you're going to have sensors. You're going to have a central control unit that knows the locations of where everything is at. And so as you start going through this whole process, you're picking up a bag, you're squatting down, you're making sure you don't put too much pressure on your bag and knock out your bag. You're going to have different types of pressure sensors and sensors that get involved in this whole process. And when you start talking about factory automation, all of these sensors have to be used. And I think a lot of times when we think about factory automation, we don't realize how many sensors are actually involved. I mean, there's thousands of sensors for every single little step that we take for granted going to a home improvement store. So now when you keep that in mind as the baseline for what we're setting up here for little power and realizing how many sensors is involved, I think this whole topic really makes a lot of sense to look into all these different areas.
Absolutely right, Simon. And, you know, the bag of fertilizer analogy is really, really, really good one that you chose. And just think about it. So when you go to grab your bag of fertilizer, you know, you want to, first of all, you're looking at it. So first sensor in question is a photo sensor, right, which are used in factory automation. So that's one type of sensor. And then you're bending down and, you know, you're trying not to, you know, throw your back out, right? So you got proper positioning. So you got position sensors, another type of commonly used sensor. And then you're grabbing the bag of fertilizer with your hands, right? And you're going to make sure that you don't like grab too hard and rip the bag open and have everything pour all over the place, right? So you've got pressure sensors. And then you're lifting the thing up and you're going to put this thing down into the shopping cart. When you place it, you want to place it and then release, not keep on pushing down and push it through the bottom of the shopping cart, right? So you have limit sensors. So you've got even more sensors. So like let's say, you know, the bag is like folded over onto itself instead of it being laid horizontal. So you've actually got, say, you know, you're using your eyes visually for this, but in the production floor, you're probably using ultrasonic sensors, right? Which are, think of ultrasonics, actually, they're on the bumpers of your car that are monitoring things as you're driving. So you've got ultrasonic sensors that are in place. And multiples of these sensors are at every single stage along the flow of factory automation. So it's almost mind-boggling because you've got so many of these sensors. They're scattered all over the place, and they're incorporated into the process so that, you know, you can't have all of these big things stuck everywhere. They're literally incorporated into the whole flow. So they're really not visible, but they're playing a critical thing. I mean, you even get sensors, you got roller sensors, like, so if you've got a conveyor system and things are rolling, they're actually built into the roller because you don't want to impede the flow of the package or the container that's moving down the flow. So all of these sensors, they're all have to be wired into something, right? Just think of your body. You've got your nervous system going from your fingers and your toes and everything, and all these nerves go into your brain. Factory automation is the same thing. You've got all of these sensors, thousands, tens of thousands, hundreds of thousands of them in a facility. They're all networked together to some unit that's kind of controlling everything. So sensors play a critical role. They are, I like to think of them as digital. They're low power, little power. They're logic level voltages. And, they're sleeping most of the time. When something is passing by them, they activate, they do their thing, then they kind of settle back down again. And this is going on the entire time this automated factory or warehouse or whatever it may be is operational.
And I agree with you, Peter. I think there's just an amazing amount of sensors that are in factory automation. It's just, it's unbelievable. Recently, the YAGEO group acquired a company called Telemecanique. How can technologies like Telemecanique has, how can that help in the low power area of factory automation?
I mean, the obvious part is that Telemecanique obviously sells all of these sensors. So Peter brought up a couple of them. You have the position sensors, you have limiting switches, you have ultrasonic sensors, and all of these different sensor types are available with that acquisition of Telemecanique now with YAGEO Group. The important part, too, that we have to start thinking about is factory automation. You don't want to just tear down a factory every time you have new sensor technology coming out. So you have to also think about scalability and retrofitting it. So Peter mentioned the sensors that go between the roller blades. So from our design perspective, we have to develop a product that can be retrofitted into something that already exists to enable factory automation. And so I think as you start going through factories nowadays, you will find that, hey, this conveyor belt system has been here for 20 years. Can we retrofit some of the new equipment to interact with some of the older parts, older motors, or whatever else they might be, and still enable them to be more modernized or smarter factory floors? And so that's really what is important when we start looking at the Telemecanique sensors that they offer.
And Pat, if I could add to that, the Telemecanique really complements what YAGEO Group already had for a portfolio of sensors. And when we look at factory automation and industrialization, if we look at some of the existing portfolio we had, we've got, ground fault sensors and current sensors that are used more tied to, as we talked about in episode number 1, the big power that comes into the factory. You got to make sure that you're monitoring this from a safety perspective. The worst thing that you could have happen is, you have a ground fault and somebody touches a piece of equipment and gets zapped. That would be terrible. You've also got other sensors that we're currently offering, which are, say, vibration sensors, which are used for predictive maintenance. If you have a drive unit, which is using electrically, there's a big inverter, which has got all of our passive components in it, capacitors and magnetics. This is driving a big motor, and that motor has a vibration profile. And should it begin to wear out and fail, that vibration profile is going to change. We make the sensors that go to that. And then everything in between the Telemecanique in the factory automation. One of the things that Simon alluded to is all of this stuff needs to be upgradable, because you're not going to go and knock down the factory in 5 years and build a whole new one from scratch. It needs to be evolving.
And you Simon mentioned the retrofit, the upgradability. What other kind of challenges are engineers facing in this, more low voltage?
I think one of the big ones is safety, right? When we start integrating new technology in old factory floors, you still have a human element, right? People are going to walk the factory floor. There's going to be certain areas that Peter already mentioned that you don't want somebody touching an equipment that then could shock them and essentially hurt them. So you have to have these ground fault detections. But there's also areas where there's going to be machines and robots that are moving heavy pieces, that are swinging around, that aren't going to look out for somebody walking into that path. And so here you have to have certain type of sensors that are like light curtains. So if somebody walks into this, I have to be able to shut down a certain section to make sure that I guarantee the safety for that particular candidate. And I think when we start looking at factory automation, we have to think of that safety factor. And oftentimes we just think, oh yeah, this is going to move, nobody's going to walk in there. But safety labels exist because somebody didn't pay attention. So in that same scenario, we have to make sure that everything is appropriately secure, that if somebody walks in, how do I shut this off? If I do a certain measurement, can I guarantee the package is in? Do I make sure that nobody has its arm in a machine that is going to cut some piece of paper and then something else gets cut? So that's one of those areas where we have to really make sure that safety is key when we start integrating factory automation in a lot of those areas.
There's one more thing to add to that, Simon, also, in that as these sensors, the number of them being incorporated is increasing, the reliability of these sensors needs to increase as well. Otherwise, as you increase the numbers, if the failure rate's still the same, you're going to have more and more outages occur. So there's work being done there to increase the robustness and reliability of the sensors. And then the other thing also is, these sensors they're not in like really nice, the room we're sitting in right now, I'm sure the sensors in it as well. This is a environmentally controlled room. Well, going back to your example of the bag of fertilizer, that is not an environmentally controlled setting. And sensors they're placed in these conditions. It can be very hot and intense sunlight hitting them during the summer. It can be freezing, frigid, cold temperatures in the winter time. Harsh substances, salts, and corrosive materials can be touching them. So all of these things need to be factored in, and these sensors, over time, we're going to see them become more reliable and more environmentally, say, resistant.
Are there any other key innovations that will help engineers face some of these challenges that they're looking for in the low power area?
So I think the main areas of innovation are, number one is and this is not new, everything gets smaller over time. Whether it's the big drive units all the way to the sensors, things are becoming more compact. They have to be, because we're placing more stuff into the same volume. So that's one thing. The other thing also is, I think over time accuracy is also increasing. So Simon mentioned in episode 1 that C0Gs or calcium zirconate-based capacitors are being used to increase accuracy. We're seeing that as a general trend, and that's not going to stop. And the reason is that movement or any parameters need to be more accurate going forward.
So looking forward, miniaturization, accuracy, what else can engineers look forward to for, in the next 5 years in the low power world?
Yeah, there's going to be more sensors, obviously, that can fit into different areas. They can do multiple jobs. And the sensor essentially is just a piece of information that gets fed into something else, right? The sensor itself can't really do anything. It's just a limit switch. It's going to be active or inactive. And that signal has to be processed. So connectivity is really a big key. As we start going into the future, all of these sensors somehow have to get the information to some central or multiple central control units. So that means as we start implementing more and more sensors, you will find that they have more and more standardized connectivity protocols that can actually be utilized in all kinds of different factory settings. So that could be I/O link or different types of connectivities that are already implemented in factory automation that's going to be seen on more and more sensors. So that information can now be fed to a multitude of control units. They can use that information to make a decision, because the sensor, again, is just a piece of provides a piece of information to somebody that can make a decision based on that.
Yeah, and Pat, I think the these sensors, they all tie into something. And for low power, I think we'll talk about this in the next episode, which is the embedded computing and the computing. I think you're going to see a lot of innovation there, which we can delve into further in the next episode. But sensors are really, just think of it as your eyes and your fingers and your hands. There's going to be more of them. They're going to be smaller. They're going to be more accurate, more environmentally resistant. And then all of them need to be communicating, whether it's through wired communication, which is the predominant way it's handled today. And then you've also got wireless communication, which is, there's some, standard protocol. Everybody knows Wi-Fi, and there's Zigbee and some other things. So those are, going to continue to evolve. But the reality is, I think, at least in factory automation, the bulk of the communication will remain wired in nature, simply because you also got to bring power to all these things.
Yep, I think that's a good point. The wired versus the wireless. So thank you guys again for participating in episode 2. And as Peter alluded to, next episode will be about embedded controllers. So we'll see you in episode 3.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.